This is topic 2 in Unit 1, Types of Data. Why classify data? What we'll find is that there is actually a number of different ways to classify data. It will seem like a nuisance originally, but depending on what type of data you're working with, depends on what type of analysis that you can do. A variable in this course is technically the same as it is in a math class. However, what we will find is that a variable will take on more types of values. So for example, a variable can be non-numeric. Specifically, a variable is an attribute that describes a person, place, thing, or idea. The value of a variable can be numeric or categorical, which means it is not a number, and can vary from one entity to another. So in a traditional math class, you are used to the variables always taking on a number. So for example, x is 10. But in this case, what we'll find is that a variable is much more broad. And for two examples, it can be the percentage of tip that a waitress receives per check or the brand of computer one owns. So it's not the variable that you typically think of, but it is basically the same idea. There are 4 different classification methods that we will be using. There are more different ways to describe data, but they do get pretty specific to certain fields. The 4 that we are talking about are the 4 most common. The first is a parameter versus statistic. The second is quantitative versus categorical. The third is discrete versus continuous. And the last is levels of measurement, which are nominal, ordinal, interval, and ratio. So parameter versus statistic is going to lend itself to the 4 definitions that we talked about in the introduction section, topic 1. A parameter is a numerical measurement that describes a characteristic of a population. A statistic is a numerical measurement that describes a characteristic of a sample. So a nice way to remember this is that parameter describes a population, statistic describes a sample. So one thing I want you to think about though is that the population is actually the result of a census when every member is polled. So you really want to think that a parameter is the result of a census. All those things do go together. The next is quantitative versus categorical. I like these two because the name itself kind of describes the variable type. So first, quantitative data are numbers representing counts or measurements. So quantitative has quantity pretty close in it. So those are going to be numbers that represent counts or measurements. So an example of a count is the number of people in statistics classes. So not all statistics classes are going to have the same amount of students. So in that definition of variable, the entity may change from one to the next. That's what this is talking about. In one of my statistics classes, I have 30 students. In another section, I have 16 students. So the value of that variable will change depending on the class. An example of a measurement, which is more familiar, is weights. Weights are the result of a measuring instrument, and so that is going to be quantitative. Those results are going to be numeric. Categorical data are names or labels, aka categories, and so this one, categorical categories, is pretty close. So some examples of these: genres of music and genders. So those aren't numeric in any way. However, number of stars awarded to a restaurant in Yelp, this is an example of a categorical variable, which can be confusing because it does have numbers in it. So a restaurant can be awarded 2 stars on Yelp. This is still a category, however, because it's not a physical 2 stars. There's not 2 stars somewhere. It's just a ranking system that Yelp uses. So even though there's a number, it's actually a categorical variable. The third is discrete versus continuous. Discrete data is data that can take on certain values. The number of possible values is finite and countable. An example of this is cylinders in a car. Cylinders in a car are only even numbers. We don't see 1.35 cylinders. We are limited only to positive even numbers. Grade point averages are also discrete. They can have more than one decimal place. It's often always rounded to 1 or 2. So grade point averages, if you were to calculate them by hand, they do take on lots and lots of decimal places, but they are always represented as 1 or 2 decimal places. So therefore, grade point averages are going to be discrete. Continuous data can take on any value within a range. The limitation in values is due to the precision of the measuring instrument that is used. So for example, commute time to school will be an example of continuous data. If I use the stopwatch to time my commute to school, I may end up getting a time of 15.22 minutes. The only reason that I stop at 2 decimal places is because that's where the stopwatch ends. If I got a different stopwatch that went to 3 decimal places, I would be capable of reporting my time to then instead 3 decimal places. So the only reason that we stop where we do with continuous data is because of the device we're using to measure. The weight of a soda can is another example of continuous data. If I took a can and I put it on a scale and got a certain weight, and then I got a more accurate scale that went to more decimal places, I could include more and more decimal places, and the only reason that I stop is just because where the measuring device stops. Finally, levels of measurements. Nominal consists of names, labels, or categories that cannot be ranked. So I think of this as N for names and nominal, and then nominal has no in it, so names with no order is the way I usually think about it. An example of this is religions. A single person may be able to rank religions in order of what they think which one is better than others. However, there's not a natural order to religions. Ordinal data, on the other hand, are names, labels, or categories that can be ranked. So ordinal, order. So for example, grades A, B, C, D, E, and F, these are just categories and labels that are put to a grade that you receive in a class. However, there is an order to them. So A is better than a B is better than a C, and so on. Another example of this is the star ranking system for movies on IMDb. So these are still, again, categories because there's not physical stars. There's just 1, 2, 3, 4, and 5 stars that are awarded. And these are to judge how good the movie is, not actual stars. Next, we have interval. This is numeric data that can be ordered. There's no natural zero starting point, and differences between values are meaningful, but ratios are not. An example of this is women's pant sizes. So the natural zero starting point, what that means is that if a woman was a size 0, she would cease to exist if 0 was meaningful. However, we know that pant sizes for women starting at 0, a woman just has a smaller waist. Differences are meaningful in this case because a woman that is a size 6 is 2 sizes bigger than a woman that is a size 4, or 1 if you want to be technical. Ratios are not meaningful, however, because a woman that is a size 10 is not twice as wide as a woman that is a size 5. So what you'll find with interval is that they are typically man-made measuring systems because 0 not having an actual meaning comes down to just a way that we classify sizes. Lastly, we have ratio. Ratio is numeric data that can be ordered. There is a natural 0 starting point, and both differences and ratios are meaningful. An example for this one is the number of children that a person has. So the natural 0 starting point in this case is that 0 means that there is a complete lack of children. There are no children. Also, both differences and ratios are going to be meaningful. For example, a person that has 8 children has 4 children more than a person that has 4 children. So 8 minus 4 is 4, and that is meaningful. Ratios are meaningful because a person with 8 children has twice as many children as somebody that has 4. So 8 divided by 4 is 2, meaning that the person has twice as many children. A few notes here. First, a variable can be described using more than one classification type. So for example, a variable can be a statistic that is quantitative, continuous, and interval. Collected data will always be either a parameter or statistic. A variable will either be quantitative or categorical. A variable will always be nominal, ordinal, interval, or ratio. However, it is possible for a variable to be neither discrete nor continuous. For example, a categorical variable of dog breed is not going to be discrete nor continuous since it is not a quantitative variable. It's not numeric. So let's do some practice with these. The first exercise, determine if the percentages are an example of a parameter or a statistic. Of the 100 senators, 38% voted yes on a particular bill. This is an example of a parameter because there are 100 senators total, and all of them participated in the vote. Therefore, this vote was a census of all of the senators. So that is why it is a parameter. The next example, the American Marketing Association put out a survey on their website asking company owners, in which of the following will your organization likely increase its focus in 2013? Respondents selected one from the following: mobile strategies, social media, marketing automation, SEO marketing, and other. 1,168 people responded to the survey, 36% selected social media. So for this example, we are deciding whether the 36% is a parameter or a statistic. So what I think is a good way to look at this one is try to see if it is a parameter, and if it fails, then it's going to be a statistic. So in order for the 36% to be a parameter, a census has to be performed on the company owners, which means that every single company owner needed to participate in this survey. So there was only 1,168 people that responded, which definitely isn't going to be a census. Furthermore, this was a voluntary survey, so people themselves chose whether or not to participate. So a company owner may have seen the survey and just simply not participated. So for that reason, this is going to be a statistic. This will lead us to the conversation of how come we don't ever see the word parameter, but we use the word statistic all the time. And that is because it's pretty uncommon for a parameter to be performed. If the data already exists and is collected completely for the whole population, then of course we would want to perform a parameter. We would want to use the parameter. However, this doesn't happen too often because most of the time when we use statistics, we are using it because it is too difficult or even impossible to pull or get information from every single member of the population. Also, what we'll find is that a statistic is a result of a sample, and a sample does a really good job at describing the population. So why would we take the time to do a census when a sample would do just as good of a job? And that's one thing I think is one of the more difficult things for the statistics student to believe, and it is something that is still pretty amazing to me. Exercise 2. Determine if the following represent discrete or continuous data. So the first example of this is the number of credits a student is currently enrolled. So when a student signs up for classes, most of the time they will be enrolling in 3, 4, 5 credit classes. So maybe a 1 credit class for a seminar or a 2 credit class for something else. We don't see typically half credits very often, and we definitely won't see 2.7593 credits. So this is going to be an example of discrete data because a person can only be in a whole number of credits, barring some exceptions with half credits, but it's not going to be something with a ton of decimal places. The next example is a person's height. So if we measured a person's height with a meter stick, and then we got a more precise measuring instrument that we were able to see in between smaller tick marks. This is something that we could keep on doing forever in theory. We can get more and more and more decimal places on this person's height. So this is going to be an example of continuous data. The more and more accurate measuring tool that we got, the more decimal places that we would be able to obtain on the person's height. Last example, shoe sizes. Shoe sizes come in whole and half sizes. So we have a serious limitation to the number of values that we can report. This is going to be discrete data because of that, only whole sizes and half sizes. One note that I want to make here is that a lot of times people think that discrete data can only be whole numbers, but we saw right here with shoe sizes that we can have a half number with it. It boils down to that limitation with the actual number rather than a tool that we use to measure it with. So it's going to be continuous if we can have more and more and more decimal places. Discrete data can have decimal places, but it is just limited depending on the value, the variable that you're reporting for. One example of this that comes up pretty commonly is money. Many times money is treated as continuous, but it is technically a discrete variable. This is because we're primarily going to round money to 2 decimal places, dollars and cents. However, there's nothing that stops you from getting $12.98725 in a calculation. It's just limited because the way that we are able to use money. So one example that you see all the time that is a division of money smaller than dollars of cents is gas prices. When you look at a gas station sign, almost always there will be a 9/10 next to the gas price. So for example, if the price of gas was $1.66, it's most likely going to actually be 166 and 9/10 of a cent. So this means that you are paying basically 167 because you're so close to that next dollar. So this is an example that you see on a daily basis where the division of the dollar is smaller than a cent, but it's still going to be discrete data because that's always the way that we will represent it, except for certain special situations. Exercise 3. Determine which of the 4 levels of measurement is appropriate for the data: nominal, ordinal, interval, or ratio. So the first example, the answer to the question, have you ever tried to read another person's diary? So the answers to this is going to be yes or no, or maybe they have forgotten. And they say, I don't know, I can't remember, but then we'll count them as a no. So yes or no themselves, if we stepped back from this example, don't have any order to them. In this problem itself, technically no would be a better answer because that means the person hasn't read somebody's diary, but just naturally yes and no don't have any order to them. So for that reason, this is going to be nominal. They are just names, categories, yes and no. There's no numerical values involved, and there's no order to them, so that will be nominal. The next example is shoe sizes. So shoe sizes is something that is numeric. So shoe sizes for kids, I mean, I think they probably go down to 0, and then they go up in whole numbers and half sizes. So we're definitely dealing with a numeric variable. So that means that we're going to be thinking about interval or ratio. And now the question is going to come down to this natural 0 starting point, as well as the differences in ratios. A lot of times the 0 starting point is enough to decide which one it is, but I usually try to be thorough and cover all 3 of those. So shoe sizes is going to be interval. If there is a 0 shoe size, it doesn't mean that that person has no foot. So there's a shoe that has a 0 on it, so it's an actual shoe. If a person has a shoe size of 4 and another person has a shoe size of 8, the difference does make sense between the 2 of them. One person has a shoe size that's bigger by 4. However, the person with the shoe size of 8, their foot isn't twice as big. So this means that the ratio is not meaningful. However, if you only use the 0 starting point, it would be enough to determine that it is an interval variable. The Third example, the letter grade that a person receives in their statistics class. This is going to be an ordinal variable. So A, B, C, D, and F, these are categories. So they're just letters that are assigned to some value. And then there is an order to them. A is better than B, B is better than C, and so on. So this is going to be ordinal. They are categories with order. Finally, we have a person's weight. So a person's weight is going to be numeric. So again, that leaves us to ratio or interval. And the 0 starting point, if something weighs 0 pounds, so let's say this is possible. So somebody gets on a scale and it says 0 pounds. There would be no weight on the scale. So 0 actually has a meaning of nothing. Furthermore, a person that weighs 220 pounds is twice as big as somebody that weighs 110 pounds. They literally have double the weight. So for every 1 pound the first person has, the other person has 2 pounds. So this is going to be ratio. Differences are also going to be meaningful in this case because a person that is 200 pounds and a person that is 180 pounds, the difference between those two people is 20 pounds, and that means that the heavier person has 20 pounds more than the lighter person. This is the end of this topic. These are the 4 different ways that we classify variables. And again, the reason that we want to do this is because the variable type does influence what type of analysis that we can do. So as we move on from Unit 1, these terms will still be present, so it's definitely something that I would make a point to be familiar with even as the course progresses.